I'm a machine learning engineer. I'm excited to present a recent capstone project we worked as a part of a data science institute course. The goal of project is to identify stroke risk among potential customers for an insurance company using machine learning techniques. Stroke is one of the most serious health event for any person he or she can experience. They often require hospitalization, long-term rehabilitation, and could even lead to disability. For insurance providers, this presents a significant challenge how to keep the prices competitive while keeping the cost low to maximize the profits. We work with a data set from Kaggle that includes demographic and health features such as age, body mass index, presence of hypertension, heart disease, ever married, even smoking status, whether he or she is a smoker or a non-smoker. One of the biggest challenge we found with the data set is highly imbalanced, meaning only few samples are having a stroke status. We focused on a data pre-processing, feature engineering while building the machine learning model and deploying to the pipeline. We tested the model using techniques such as logistic regression, random forest, and XZ classifier. To manage the class imbalance, we use techniques such as SMOT, which is oversampling the minority class, and also tune the hyperparameter using cross validation. We also used ML Flow to track the experiment, compare the model performance, and of course log the parameters and evaluation metrics such as confusion matrix, um, accuracy score, F1 score, precision, and recall, so that the models can be iteratively trained and deployed. Interestingly, we found that logistic regression, which is a simpler model, uh, performed nearly as good as a complex model such as XZ classifier. Well, of course, this also involved a good pre-processing, cleansing the data for the missing values, and of course, oversample the minority classes so that we could balance the data set. We selected logistic regression as our final model due to its strong performance and, of course, its explainability using sharp values, which is important, in financial and insurance industries. Our final model achieved overall 80% accuracy. This is to able to correctly identify the majority of stroke cases while keeping the false alarms low. This balance is definitely critical in insurance industry so that not too many false positives, not too many false negatives. We wanted to some balance, between the false positive and false negatives. We not only train the models but deploy to cloud using Fast API, Azure ML. Not only deployment, we also use tools like Grafana, Dynatrace for real-time monitoring and data and model drifting. Overall, this is a fun experience to implement the model, but also deploy to cloud so that in production you can actually make a call from a web such as a front-end React application and get the inference at a live. Well, we try to keep the inference time in less than a minute or so. Some of the key lessons I got from this project: data quality and, of course, quantity, class balance is paramount for model performance. Second, even simpler models like logistic is equally comparable when compared to complex model like XGBoost classifier. And finally, last but not the least, communication and Teamwork collaboration is equally important while building a world class solution for customers. Thank you.